On to problem 4-2, patterns in slope triangles. At this point, hit pause and read through the introduction, as well as letter A. Hit play when you've done so. So in order to find an angle like the one from the Leaning Tower of Pisa problem, we're going to study these slope triangles. And we're going to start by drawing 3 new slope triangles on this line. Now, how can you draw on something using your Chromebook? For me, I have an iPad, and so I can use Notability. And so I bring the resource page into Notability, and I can draw on it here. For you, on your Chromebook, you also have an option to draw on PDFs. And so if you go to Google, so here you are at google.com, and you log in with your SAUSD Learns account, and next to your image, you click the waffle to get this menu. If you scroll all the way down, you should see Lumen PDF right here. And so click Lumen PDF, and then you're also going to log into this with your SAUSD Learns Google account. Once you've done so, you can hit the plus button. Once you've done so, you can hit the plus button and upload your files. And so here I have the files that I've downloaded. There is the resource page, and then I can open it and mark on it here. Whatever you want to do. Okay, so go ahead and use Lumen if you're using a Chromebook. So we're going to draw 3 new slope triangles. I'm going to draw the first one, and then you can draw the other 3. So in order to draw a slope triangle, it has to go from one lattice point like this, where 2 of these grid lines cross, to another one. And so I'm going to mark all of the lattice points on this line, and that will help me draw my slope triangles. Now remember, they each need to be of a different size. So my first one, maybe I'll start here, and I'll go here, and there. And so this is 10, and that's 2. Now, why don't you go ahead and draw 2 more slope triangles and label the horizontal length and the vertical length. Hit pause and then play when you've done so. Now that we have all 3 new slope triangles drawn and labeled, let's move on to letter B. B, explain why all of the slope triangles on this line must be similar. So what I want you to try and do is to prove that they're similar using one of the similarity theorems from chapter 3. Hit pause, maybe look at a toolkit or do some Google research, and then play when you think you've proven it. Well, if we look at all of these, we can prove that they're similar by angle. So they all have this right angle. That's one angle. And then as they show us here, this angle right here is 11 degrees. And since the bases of all of these are parallel horizontal lines, this line creates the same angle with all of those. And they are all similar. They are similar by angle similarity. Letter C. Since the triangles are similar, what does that tell you about the slope ratios? So if we know that shapes are similar, we know that they have congruent angles. The corresponding angles are congruent. And then what else is true about the sides? Hit pause, take a moment, and look back and try to answer letter C. Hopefully you remember that if triangles are similar, then corresponding side ratios are the same. Therefore, all the slope ratios will be the same. On to letter D. Confirm your conclusion by writing the slope ratio for each triangle as a fraction, such as delta y over delta x. That little triangle there means change, or delta, the Greek symbol. Then change the slope ratio into decimal form and compare. So what I want you to write here are two things below. I want you to write slope angle equals, and then write slope ratio equals. So our slope angle is this bottom left angle of each slope triangle. And we'll go ahead and mark it here. And so our slope angle is 11 degrees. Go ahead and calculate the slope ratio. Again, the slope ratio is change in y over the change in x, or rise over run. Hit pause, try and find that, and then hit play. So hopefully you saw in all of these, the slope ratio is 1/5, 2 over 10, 3 over 15, or 5 over 25. And you could simplify all of those to equal 1 over 5. So there's our slope angle, and there's our slope ratio.